sequence? A sequence is a collection of numbers arranged in a definite order according to some definite rule. Let us consider the list of numbers 4, 8, 12, 16 and so on. Do this list form a sequence? Yes, they form a sequence. Why is it a sequence? It is a sequence since the numbers are arranged in a definite order. The number in the first position is 4 into 1. Second position is 4 into 2. Third position is 4 into 3 and so on. Now, what should be the number in the 25th position? The number in the 25th position is 4 into 25, which is 100. What should be the number in the nth position? The number in the nth position is 4 into n, which is equal to 4n. Let us consider another list of numbers. 3, 9, 27, 81 and so on. Do this list form a sequence? We can arrange the numbers as 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4 and so on. Now the pattern is very clear. Therefore, 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4 and so on is a sequence. What should be the number at the 42nd position? Since the number in the first position is 3 raised to 1, second position is 3 raised to 2, third position is 3 raised to 3 and so on, the number in the 42nd position should be 3 raised to 42. What should be the number in the nth position? The number in the nth position is 3 raised to n. General term of a sequence. In a sequence of numbers, the number in the first position is called the first term, denoted by T1. The number in the second position is called the second term, denoted by T2. The number in the third position is called the third term, denoted by T3 and so on. The number in the nth position is called the nth term, denoted by Tn. Tn is the general term of a sequence. In the sequence 3, 9, 27, 81 and so on, T1 is 3, T2 is 9, that is 3 raised to 2. T3 is 27, that is 3 raised to 3. T4 is 81, that is 3 raised to 4, and so on. Tn is 3 raised to n. In the sequence 4, 8, 12, 16 and so on, T1 is 4, T2 is 8, T3 is 12, T4 is 16 and so on. Tn is 4n. Usually we denote the sequence by its nth term as shown. It is read as sequence Tn, where n is a natural number. Since the nth term of the sequence is 4n, we can denote the sequence as sequence 4n. Let us now solve a few examples to find the next 4 terms of the given sequences. In example, the given sequence is 1, 2, 4, 7, 11 and so on. What is the order followed in this sequence? Here, the first term is 1. 1 is added to the first term to get the second term. 2 is added to the second term to get the third term. 3 is added to the third term to get the fourth term. 4 is added to the fourth term to get the fifth term. In this order, which number is to be added to the fifth term to get the sixth term? 5 is to be added to the 5th term to get the 6th term. This means 11 plus 5, which is 16. What will be the 7th term? The 7th term is 16 plus 6, which is 22. Similarly, 8th term is equal to 22 plus 7, which is 29. And the 9th term is equal to 29 plus 8, which is 37. Therefore, the next 4 terms are 16, 22, 29 and 37. The next sequence is 192, minus 96, 48, minus 24 and so on. In this sequence, how do you obtain the second term from the first term? If you divide the first term 192 by minus 2, we get the second term minus 96. How do you obtain the third term from the second term? If you divide minus 96 by minus 2, you get 48, which is the third term. What is the pattern followed in this sequence? In this sequence, each term is obtained by dividing the previous term by minus 2. What will be the next term after minus 24? The next term after minus 24 is minus 24 divided by minus 2, that is 12. Now we can find the next 3 terms in the same way. 12 divided by minus 2 is minus 6. Minus 6 divided by minus 2 is 3. And 3 divided by minus 2 is minus 3 upon 2. Therefore, the next 4 terms of the given sequence are 12, minus 6, 3 and minus 3 upon 2. The next sequence is 1 upon 2, 1 upon 6, 1 upon 18, 1 upon 54 and so on. In this example, each term is obtained by multiplying the preceding term by 1 upon 3. Therefore, the term after 1 upon 54 is 1 upon 54 into 1 upon 3, which is 1 upon 162. The term after 1 upon 162 is 1 upon 162 into 1 upon 3, which is 1 upon 486. The next term is 1 upon 486 into 1 upon 3, which is 1 upon 1458. The term after that is 1 upon 1458 into 1 upon 3, which is 1 upon 4374. Therefore, the next 4 terms of the given sequence are 1 upon 162, 1 upon 486, 1 upon 1458 and 1 upon 4374. The next sequence is 0.1, 0.01, 0.001, 0.0001 and so on. It's easy to find the terms if we write the sequence as 1 upon 10, 1 upon 100, 1 upon 1000, 1 upon 10,000 and so on. Therefore, the next 4 terms are 1 upon 1 lakh, 1 upon 10 lakhs, 1 upon 1 crore and 1 upon 10 crores. This means the next 4 terms in decimal form are as shown here. We have seen how to find the remaining terms of a sequence when the first few terms are given. Now, let us see how to find any term of the sequence whose nth term is given. Consider the sequence 4n minus 3. What is meant by sequence 4n minus 3? Sequence 4n minus 3 means its nth term Tn is 4n minus 3. How will you find the first term of the sequence? To get the first term, substitute n is equal to 1. Therefore, T1 is equal to 4 into 1 minus 3, which is equal to 1. How will you get the second term? To get the second term, substitute n is equal to 2. Therefore, T2 is equal to 4 into 2 minus 3, which is equal to 5. Similarly, T3 is equal to 4 into 3 minus 3, which is equal to 9. T4 is equal to 4 into 4 minus 3, which is equal to 13. Can you find the 25th term of the sequence? Yes. If you substitute n is equal to 25, you will get T25. Therefore, T25 is 4 into 25 minus 3, that is 97. In this way, we can find any term of the sequence whose nth term is given. We will now solve a few examples to find the first 5 terms of the sequence whose nth term is given. In the example, the nth term Tn is given as n plus 2. To find the first term T1, substitute n is equal to 1. Therefore, T1 is 1 plus 2, which is equal to 3. To find the second term T2, substitute n equal to 2. Therefore, T2 is 2 plus 2, which is 4. Similarly, T3 is 3 plus 2, which is 5. T4 is 4 plus 2, which is 6. And T5 is 5 plus 2, which is 7. Thus, the first 5 terms of the sequence are 3, 4, 5, 6, 7. Let us solve one more example. Here, Tn is given as n square minus 2n. Substitute the values of n as 1, 2, 3, 4 and 5 to get T1, T2, T3, T4 and T5 respectively. T1 is 1 square minus 2 into 1, which is 1 minus 2, which is minus 1. T2 is equal to 2 square minus 2 into 2, which is 4 minus 4, which is 0. T3 is 3 square minus 2 into 3, which is 9 minus 6, which is 3. T4 is 4 square minus 2 into 4, which is 16 minus 8, which is 8. T5 is 5 square minus 2 into 5, which is 25 minus 10, which is 15. Thus, the first 5 terms of the sequence are minus 1, 0, 3, 8 and 15. We will now learn how to find the sum of the first n terms of a sequence. In general, the sum of the first n terms of a sequence is denoted by Sn. Therefore, the sum of the first term is denoted by S1. Sum of the first 2 terms is S2. Sum of the first 3 terms is S3, and so on. Let us take an example. Consider the sequence 1, 2, 3, 4, and so on up till n-1, n. In this sequence, we know that T1 is 1, T2 is 2, T3 is 3, and so on. Tn-1 is n-1, and Tn is n. Therefore, S1 is 1, which is the first term T1 itself. What is the sum of the first 2 terms of this sequence? To find the sum of the first 2 terms, we have to add the first 2 terms. Therefore, the sum of the first 2 terms S2 is 1 plus 2, that is T1 plus T2. What is S2 minus S1? S2 minus S1 is T1 plus T2 minus T1. By cancelling plus T1 and minus T1, we get S2 minus S1 is T2. What is the sum of the first 3 terms? The sum of the first 3 terms S3 is 1 plus 2 plus 3, that is T1 plus T2 plus T3. What is S3 minus S2? S3 minus S2 is T1 plus T2 plus T3 minus of T1 plus T2. That is, S3 minus S2 is T1 plus T2 plus T3 minus T1 minus T2, which is equal to T3. In the same manner, can you find the sum of the first n-1 terms of the given sequence? The sum of the first n-1 terms, that is Sn minus 1, is equal to 1 plus 2 plus 3 and so on till n-1, which is same as T1 plus T2 plus T3 and so on till Tn-1. Now, what is the sum of the first n terms? The sum of the first n terms Sn is 1 plus 2 plus 3 and so on up till plus n-1 plus n, which is nothing but T1 plus T2 plus T3 and so on till Tn. What is Sn minus Sn minus 1? Sn minus Sn minus 1 is equal to T1 plus T2 plus T3 and so on up till plus Tn minus 1 plus Tn minus T1 minus T2 minus T3 minus and so on up till minus Tn minus 1. Cancelling the like terms, we get Sn minus Sn minus 1 is equal to Tn. Thus, we get S1 is T1, S2 minus S1 is T2, S3 minus S2 is T3, and so on. Sn minus Sn minus 1 is Tn. This means Tn is Sn minus Sn minus 1. By using this equation, we can find any term of the sequence when Sn is given. Let us solve an example to find the first 3 terms of the sequence when Sn is given as n into n plus 1 into 2n plus 1 upon 6. First, let us find S1, S2 and S3. Sn is given as n into n plus 1 into 2n plus 1 upon 6. By substituting n as 1, we get S1 is 1. When n is 2, S2 is 5. When n is 3, S3 is 14. Now we will find T1, T2 and T3 by using S1, S2 and S3. Therefore, S1 is equal to T1 is equal to 1. T2 is equal to S2 minus S1. Substituting the values of S1 and S2, T2 is 5 minus 1 equal to 4. T3 is S3 minus S2. Substituting the values of S2 and S3, we get T3 is 14 minus 5, which is 9. Therefore, the first 3 terms of the sequence are 1, 4 and 9.